Okay, today we're going to be working through the word problem at the top here. Maria and Oscar decide to race each other's new remote-controlled cars. Since Maria won first place at last week's competition, she decides to give Oscar a head start. Oscar begins with his car 2 feet ahead of Maria's. Oscar's car can move 2 feet per second and Maria's moves 3 feet per second. How long into the race Maria's car tied with Oscar's? So this is going to be using a system of equations, and we're actually going to graph each of our equations, one for Maria and one for Oscar, to see if we can determine when they would tie each other in the race. So the first thing we have to start with is writing our equations for each person in our story problem. So we're going to start with Maria. So for Maria, y equals, her slope is actually going to be her car's speed. So it says in our word problem that Maria's car moves 3 feet per second. So she is moving 3 feet for every second. So second is on our x-axis, so that's why our slope is 3x. And then if we want to, we can actually add her y-intercept. Since Maria's starting at the official starting line, she's not getting a head start, we can go ahead and put her y-intercept as 0. And so this is Maria's first equation. So that will give us, depending on time, how far Maria's car has traveled. And then we're going to do the same for Oscar. So again, we're starting with y equals. This time, Oscar's slope is going to be 2 feet per second. So 2 feet for every x, 2 feet for every second. Again, our seconds on our x-axis that he travels. But he got a head start in our word problem. Oscar got a 2 feet head start from Maria. So Oscar's y-intercept is going to be +2, since he is 2 feet in front of where Maria is. She has the y-intercept of 0. So here's our two equations. And so what we're looking for is when they will tie. So if we're going to plot these equations on our graph here. So what we're actually looking for is where these two lines would cross. Because eventually, since Maria's car is faster than Oscar's, eventually Maria would outrun Oscar. But we're actually looking for the specific keyword here is tie. Where does their car tie with each other? So we're looking for where do these two equations intersect. Where they intersect, that's where the two cars would be at the same location at the same time where they're tying. So let's go ahead and start by graphing Maria's car. So I'm going to switch to dots here. So the first point we can plot is the y-intercept, which is 0, 0 in this case. So we'll use blue for Maria. And I'm going to go ahead and actually make her name blue so that we remember that Maria is going to be our blue dot, our blue line. So there's our first point. Our slope is 3. So to plot our next point, we are going to be moving up 3, 1, 2, 3 over 1. Okay, center that. Same thing again. Up 3 over 1. Up 3 over 1. And so here we can kind of see the line that Maria's car is moving. So let's go ahead and connect that with our blue line to kind of trace Maria's car's trajectory. So there's Maria's plot. So we can see after 1 second, she's 3 feet ahead. After 2 seconds, she's 6 feet ahead, 3, 9 feet, and that would continue beyond our graph. Next, let's go ahead and change Oscar's color. Let's go ahead and make Oscar orange so that we can really tell the difference between these two. So again, I'm going to go back to shapes, and we're going to start with Oscar's y-intercept. Our +2 means that Oscar is starting 2 feet ahead. Let's go ahead and change our color to orange. And this time, Oscar's slope is only 2 feet per second. So starting here, we're going to be moving up 2 over 1, up 2 over 1. We can kind of start to see that overlap. Up 2 over 1, and then up 2 over 1. And so here we can draw a line again to connect Oscar's path. And let's go ahead and change our line to orange. Perfect. Okay, so now we have Maria's line, her system of equation, or her equation graphed, and we have Oscar's equation graphed. So looking at these two plots, again, we're looking for where they tie, which would be where they intersect. So if we follow our point here, they're intersecting at the location. Our x value is 2, and our y value is 6. So let's go back to our word problem so we can actually answer the question. How long into the race will Maria's car tie with Oscar's? So we're actually thinking about time is what we're concerned about. So we only need our x value to answer our question, since our x value is measuring our time for that how long. So our final answer to this word problem is Oscar and Maria will tie. Oscar and Maria will tie after 2 seconds, because 2 is where our x measure is, where these two lines intersect.